Hey everyone, welcome to today's Explainer. If you've ever felt that absolute cold sweat of bringing down an entire network with just one fat-fingered command line typo, well, this one is absolutely for you. Today, we're decoding the raw engineering blueprint of network programmability and automation. We're going to strip away all the fluff and uncover exactly how modern networks evolved from human-driven terminals to massive software-driven systems. And, of course, we'll meet the master orchestrator pulling all the strings behind the scenes.
Okay, let's dive into this. We're building this up step by step today. We'll start with a shift to automation, look at REST API fundamentals, break down JSON syntax rules, parse an actual JSON payload, and finally, look at the controller's role.
All right, Section 1, the shift to automation.
Look, the core problem that network programmability solves is actually pretty obvious, right? On the old imperative side of things, you've got a human administrator literally SSH'd into a single router, manually typing out commands. It's incredibly tedious, it's strictly per device, and honestly, it is super vulnerable to human syntax errors. But on the declarative side, we completely replace the keyboard with software-to-software mediation. It's designed for massive scale, and here's the thing to keep in mind. If we're letting software manage the network on a massive scale, we're eventually going to need a master controller to oversee the whole shebang.
Moving right along to Section 2, REST API fundamentals.
So, what exactly is the software mediator that replaces our clunky human command line? Enter the REST API. It's actually fascinating because it simply leverages the ubiquitous HTTP methods we already use on the web to allow our automation scripts to ask a router or a controller to take an action. It's the ultimate bridge, seamlessly connecting two completely distinct software systems.
Now, a REST API relies on some pretty strict architectural traits to work its magic. Notice the concept of statelessness here. This is an absolutely crucial constraint. See, the server does not store any information at all about the client session. Nothing. This means every single request your script sends must contain all the necessary authentication and state data. The request just has to stand completely on its own.
And get this, instead of forcing you to memorize proprietary command line syntax, this API manipulates network resources using the exact same HTTP verbs your web browser uses every day. It's a direct, one-to-one map to basic CRUD actions. A GET request that reads a config. A POST creates something entirely new, like spinning up a brand new VLAN. Put or patch updates and modifies things, and delete, well, it deletes them. We are literally managing physical enterprise-grade infrastructure with basic web commands. It's a real game changer.
Which brings us to Section 3, JSON syntax rules.
So when those HTTP verbs are executed, how does the data actually look? Well, we use something called serialization. Serialization is that critical translation layer. It takes the router's internal state and formats it into a highly structured payload that your automation code, like a Python script, can parse instantly. And for modern networking, JSON is the undisputed king of these formats.
Since JSON is meant to be read by machines, it enforces incredibly strict grammatical rules. You've got key-value pairs separated by commas, and keys must be strings and double quotes. But here's the absolute critical distinction you have to remember when building out your automation: the bracketing. Curly braces depict an object, which is a specific dictionary of traits. Square brackets, on the other hand, dictate an array, an ordered list. Knowing exactly when you're looking at an object versus an array is the secret to flawlessly reading JSON.
Let's see this in action in Section 4, parsing a JSON payload.
Let's systematically track how a machine actually navigates a real-world JSON example. We enter at the root object, designated by that first curly brace. Next, we find our top-level key, say Cisco iOS XE native. From there, we drill down to a specific config key, mapping hostname directly to something like Visualnet branch router 01. Then we hit the gigabit Ethernet key and suddenly, boom, a square bracket appears. Instantly, your code knows an array of interfaces is next, and that array is packed with individual interface objects.
And this brilliantly illustrates how raw syntax becomes live network state. Look at the data pulled right from that array. Interface 1/0/1 has a description of SD-WAN, and its shutdown status is false, meaning it's live and active. Just below it, interface 1/0/2 for the guest Wi-Fi has shutdown set to true. No more manually parsing through giant messy walls of CLI text. Your script just reads the keys and instantly knows the exact operational status of the hardware.
Finally, the main event. Section 5, the controller's role.
All right, it's time for a quick reality check. Everything we just looked at, the APIs, the JSON payloads, that allows your computer to beautifully automate exactly one single router.
But enterprise networks, they are made of hundreds, sometimes literally thousands of devices. You absolutely cannot write and manage individual API scripts for 1,000 different endpoints. To orchestrate this gracefully at scale, we need to introduce the controller.
An SDN controller, like Cisco DNA Center, acts as the central brain. It's your single pane of glass. But here is the massive paradigm shift. The controller itself exposes its very own powerful REST API. Because the controller is managing the underlying hardware, you no longer need to write code to talk to individual switches. You just write code that talks directly to the controller, and the controller handles translating and pushing those JSON payloads down to the entire fleet.
To really wrap your head around this, you just have to look at the literal directionality of the communication. It's a bridge with two halves. Northbound APIs are exposed by the controller pointing up to your management scripts and business applications. That's what you talk to. Southbound APIs, on the other hand, point down to the physical hardware, using protocols like REST, netconf, or even legacy CLI. You speak API to the controller, and the controller speaks whatever is necessary to the metal.
So, we've decoded the whole evolution, from error-prone human typing to structured JSON, all culminating in the SDN controller orchestrating the network at a massive scale. It's a totally different world. So I want to leave you with this provocative thought. Now that the controller is seamlessly handling all the heavy lifting of the physical hardware via those southbound APIs, what innovative, network-wide automations are you going to build with its northbound API? Think about it. Thanks for joining me on this explainer, and keep building.